Hello everyone, welcome back to Calculus 1. And again, this part, it is for reviewing purpose. This is the continued part to review some basic algebra knowledge necessary for calculus. And in the first part, we covered some multiplication formulas and the factorization formulas, and also we talked, I say, quite a bit about exponentials. And in the end, we mentioned logarithm. I said two things about logarithm. A logarithm, really, it is used to denote an exponent. And that exponent really comes from a corresponding exponential term, a power term. Okay. And also I said a logarithm mathematically precisely. It is the inverse of an exponential. So accordingly, when you have an exponential term in this fashion, b raised to the power of y equals x, and then y can be written as log base b of x. Log base b of x. Okay, that is a logarithm. Well, it's hard for me to do the type and to talk at the same time on the screen on the computer. I'm trying to present this very simple example to see if you can follow. For example, if we are having 2 to the power of 3 equals x, and then accordingly the logarithm would be log base 2 of 8 equals 3. 2 to the power of 3 equals 8. Then accordingly in a logarithm fashion, it is log base 2 of 8 is 3. That is really how I understand the logarithm, because it is considered reviewing purpose, so I really did not provide any detailed examples on the notes, and I'm asking you to do me a favor, do yourself a favor, to see if you can write down 1 or 2 examples for each formula I provided on the video and on the notes, and then do give a try if you are convinced by yourself. They all make sense, okay? And particularly for logarithm. And now let's take a look at a special case of logarithm. Log base b of 1. Log base b of 1, well, if you think very carefully, what comes to in my mind is I must have something b raised to the power, some power equals 1. And then you think about the exponential property, or how exponentials are created. B to the power of 0 is 1, right? So log base b of 1 equals 0. And also I suppose you know natural logarithm, right? Log n of 1 equals 0. Log logarithm with any base of 1, it is always 0. Okay, I think I mentioned the logarithm, natural logarithm. Natural logarithm, it is a logarithm, but anyway, it is written as ln of x. And it is a logarithm with base e. Do you know what is this e? Okay, I suppose you do. You do. E, it is the Euler's number. It is the Euler's number. It's about 2.71828. Okay, that's the natural logarithm. And also many times you may see a logarithm without a base. Log of x. And I want you to know this is the common logarithm, log base 10 of x. It still carries this name, but anyway, nowadays, when we use logarithm, we really don't use the common logarithm at all. Okay, the common logarithm, it's very common. I say probably in the early 20th century, 1900 or even earlier, because there are somewhat so people develop techniques to handle the logarithm with base 10. Nowadays, with the advance of technology and the calculate, and really whenever mostly we talk about the logarithm, we meant the natural logarithm. Nowadays, the natural logarithm. It is the most commonly used logarithm. But the log base 10, it still has a name, the common logarithm, but it's not common anymore, honestly, okay? Logarithm. Remember, we have some properties of exponentials and logarithms. Logarithms are created from the exponentials. So accordingly, those laws of exponents can be converted into laws of logarithms. Laws of logarithms. Log base b of x plus log base b of y turns out to be log base b of x times y. Put into words, I'm saying when you're adding two logarithms with the same base, they can be converted into a single logarithm by multiplying x and y together. When you subtract two logarithms, still you can combine those two logarithms into this fashion, x over y. And also another case when you have the combination logarithm and exponential combined, mixed. Okay, and then it still can be simplified. Log base b of x to the power of r, it is the same as r times log base b of x. And accordingly, we do have, when we use logarithms and exponentials, we do have logarithmic functions and exponential functions. So the second part of the reviewing material, it is about types of functions. And actually one thing just come to my mind, I should have mentioned before I move to the reviewing part for functions. Okay, logarithms, because these are supposed to be reviewing material and we are doing calculus 1. And I want you to take a different look about those two properties. Okay, from the point of view of calculus, maybe can I say it's somewhat at an advanced level, somewhat higher than the level of algebra. You look at those two properties of logarithms and read the property from right to left. Would it make sense to you? I'm reading this line here from right to left. Can I say in a rough way, not precisely, okay, in a rough way, I'm saying we could use a logarithm to convert multiplication into addition, right? And similarly, this is part of property, which really means that we could use a logarithm to convert division into a subtraction. Actually, these two observations are very important. And I suppose you know in calculus, we are going to study limits, derivatives, and integrals. Limits, derivatives, and integrals, three things. And a bigger task, it is to find out derivatives. And somewhat, we only have limited rules and formulas for derivatives. And it would be somewhat more complicated to handle derivative product or derivative quotient. So if you understand and if you do see, okay, using logarithms, there are ways to convert multiplication into addition and division into subtraction. And indeed, they will help a lot handle derivatives. But anyway, for now, the only requirement is make sure you do know logarithms and exponentials very well. So far, so good. So if you have any questions, send me email. And also I'm doing those online sessions. You can join those online sessions. And also if needed, we can add more of those online sessions. Okay. I'm going to do a little bit more about reviewing. The second part of reviewing is types of functions. And I want you to know, instead of considering like linear functions, quadratic functions, from point of view of calculus somewhat, we look at the function types in a little different way. So the first type I want to mention here is the so-called power functions. X to the power of r. Okay, this is an exponential term. X is the base, r it is the power. X, it is a base, and it is a variable. It is a variable, which means it could be of any number, okay? And the R, it is a constant. But anyway, specifically R, it is also a real number. In calculus, mostly we just use real numbers. So this R could be 1, R could be 2, okay? So for example, as I'm saying, x squared, x cubed, those are the power functions. And remember, when we talk about the exponent, an exponent could be positive, could be negative, could be fractions, right? So indeed, this R could be negative. X to the negative 1, which is 1 over x. So that is a rational function. In general, we really don't consider rational functions the same like as x squared, x cubed. Those things, they are totally different. But anyway, when we consider power functions, they are in the same family. And also we could have x to the negative 2, that's 1 over x squared. X to the negative 3, that's 1 over x cubed. Okay, they are in the same family. They are different functions, but anyway, they are in the same family. And also, the R is a real number. Could be positive, could be negative, could be fractions. Like R is 1/2. Remember, to the power 1/2, it is square root of x. Square root of x is different from 1 over x. It's different from x squared. But anyway, still, they are in the same family. They are in the same family. X to the 1/3, that's third root of x. X to the 1/4, that is the fourth root of x. Okay, so those radical functions, they also can be considered power functions. And again, I want to let you know the reason we put them in the same function. Indeed, in calculus, when we work with derivatives, okay, we do have the same power rule to find out derivative of those different functions because they all can be considered as power functions. And furthermore, when we have power functions, we may have to deal with raising to the power of negative fraction. So x to the negative 1/2, that's 1 over square root of x. X to the negative 1/3, that's 1 over third root of x, and so forth. Power functions, it is really a huge family of functions, a big, really big family of functions. They include, it does include the family, does include a lot of different functions, okay. And now let's go back to the things we might be very familiar with, like linear functions. This is a linear function, right? Linear function. And the linear function, I say it is generated from the power function, especially we use this x only to generate. Multiply x by a constant, then add another constant. That is a linear function, okay. And also we may have quadratic functions. I'm saying quadratic function, it is generated by multiply x squared x with some number, then add a constant. And indeed, we could go further, the third degree polynomial, fourth degree polynomial. So I'm saying in general, polynomials are generated from power functions using addition, subtraction, and multiplication. And also, if you consider division of power functions, basically, we also can get the other bigger group of functions, rational functions. Okay, a rational function in general, it is a quotient of two polynomials. Quotient of two polynomials. And let me just talk a little bit more about linear functions. Okay, before we take a break, a linear function always can be represented in this fashion. The graph of linear function is a straight line, and specifically this fashion of the linear function, it is the so-called slope-intercept form of line. M is the slope, and B is the y-intercept. And specifically, I want to mention the slope. Slope, it is rise over run. Rise, it is change along the vertical direction. Run, it is change along the horizontal direction. So slope can be calculated as rise over run. And this is for line. And Indeed, the slope concept, it is extremely important in calculus. In calculus, we study limits, derivatives, and the integrals. Put in a simple way, I want to tell you for now, what is a derivative? Derivative is slope. Hey, thank you for watching, and we will continue to review in the next part. Thank you.